And the topic is finding roots of a polynomial. And the essential questions are this, and those people on the other end have got this copied. And for here in class, they're on the board, so I'm going to go ahead and scoot over here. And we're going to look at this next question. And think about multiplying by 0. And think about what is the solution for each of those things, and how do you know? What is the solution for each of those questions in the negative equation? And how do you know what the answer is? Zero. Okay, how do we know? How do we know it's 0? Anything multiplied by 0. Yeah, that's essentially like a silly thing for algebra class, right? It's real simple, that kind of stuff, but we're going to use this idea today. Okay? So if anything multiplied by 0 is 0. Okay? So let me ask you this. New question. And let me repeat that for here since I was a little further away. That the answers here were all 0 because anything multiplied by 0 is 0. And so now this is the question's a little different. I'm going to show the problems in a second. It says, what is the value of the variable for the letter? How do you know that's the value of the letter or the variable? So here's some examples. So like in the first one, since 3x equals 0. What is the value? Let's take that out. Right there. All right, so what do you guys get? What did you guys get for x? What do you see? What did you get? How did you know it was 0? Because the other number's 3, the x has to be 0, right? How about the next one? Anthony, what's the n? How did you know? How come it has to be 0? Yeah, and that you have a 5, so the other number has to be 0, right? Okay. The next two are a little trickier, weren't they? I wonder, what do you think about the M? What could the M be?
0.
Okay, does it have to be 0?
No.
But it could be 0, right? Do we know if it's the M or the M that's 0 by looking at it? No, we don't. So we could say that the M is 0.
And the other one is 0.
Okay, or the N could be 0, right? Then the M could be any other number. But we don't know which one's which, do we? And that was why I put it that way, because I want us to understand that. The M could be 0, or the N could be 0, but we don't know which one's which. Okay? They both could be 0, couldn't they? Okay. How about the A, B, and C? Is that the same situation? The A could be 0, or the B could be 0, or the C could be 0. We don't know which one it is, though, right? We don't know for sure which one it is. And that's okay. One of them has to be 0, though, doesn't it? All right? So keeping that idea in our head, we're going to take that idea and we're going to use that idea a little bit later. But that idea of if you multiply numbers together and the answer is 0, one of them has to be 0. It's called the zero product property. And we're going to use this idea today. And it says for any real numbers, A and B, so real numbers is like decimals, fractions, positive, negative numbers, and so on. For any real numbers, if A times B equals 0, then A equals 0 or B equals 0, which is exactly what we just said, isn't it? Okay? So I'll give you a chance to get that copied down. You guys ready? All right, so let's look at an example that's a little bit more challenging than just the A times B equals 0. Okay? Let's look at this example. It says x plus 1 times x minus 2 equals 0. So what is that telling me? What do you think I should do if I was thinking about that? What does that tell me based on what we know right now? Okay. That's a good thought. That's a good thought. Somebody else have another thought? There, let's take a 0 there. Maybe that's another thought. Okay. So let's try that. Let's try what Melinda said and see what happens. If I put 0 in for x, it would be 0 plus 1 times 0 minus 2. Is that going to equal 0? No. Okay, so I think you're on the right track here. Something has to be 0, right? But just putting 0 in for the variable isn't going to work. And so let's stop and think about this for a second. Remember, I'm going to clear this. Remember that when I have like an x plus 1, those are two parts that make a single number, okay? Because the 0 plus, not that the 0, it became 0 plus 1, which is actually just 1, right? So that part in parentheses, the x plus 1 represents a single number. And that single number has to equal 0, doesn't it? Okay? So that means this part right here is the first set of parentheses, or this part right here, the second set of parentheses, is a single number. And one of those single numbers has to be 0, doesn't it? Okay? We know one of those has to be 0. So what we end up with is actually x plus 1. I don't even need the parentheses anymore, but I put them on there, equals 0, because that says that single number x plus 1 makes 0, right? Or x minus 2 is going to equal 0, because x minus 2 represents a single number. That makes a difference on what the variable is, doesn't it? Or what the variable's worth now, doesn't it? Okay. So what's the variable worth on the first one? -1, right. So x is -1 in the first one. And what about the second one? Somebody different. Lisa, what's the? It's 2, right. Because 2 minus 2 is going to make 0, right? Okay. So if I actually go and put those numbers back in the equation, then we're going to get 0 on each one of those, aren't we? So the first one would be 0, or the second one could be 0 then, right? Do we know which one is the one that's 0? No. So that's why we have to solve for both of them. Because one could be 0 or the other one could be 0. Does that make sense? Okay? And you just have to remember that that part in parentheses represents a single number, even though it has 2 parts. It gets a little confusing, doesn't it? Okay, but that's what it's talking about. All right, so we've got this idea to use today, and the parts right here, that looks a little familiar, just like it's working with, doesn't it? Okay, so if we didn't have it equal to 0, did we? Okay, so we're going to take that idea, this idea, and we're going to use it with stuff we've been working with. So we're going to take what we learned, like with the factoring and stuff like that, and we're going to take it a step further. So, but before we get there, let's just refresh our memory on how we factor polynomials. Okay, so how do I factor this? What's the first thing I needed to do here? Remember? Yeah, I'm going to make my box, so my generic rectangle. I'm going to call it a generic rectangle because I'm really I've given you the area of that rectangle, haven't I? And I'm asking you to find the length and the width. Oops. I got that. All right, so what goes up in the upper left-hand box? X squared. In the lower box, 3. And then we have to figure out how to split the 4 between the other 2 boxes, right? How do we split that up? How do we group it with the x squared or the 3? Yeah, remember we used the diamond problem, the x problem, to help us with figuring out how to group it, didn't we? So we didn't have to kind of guess and check all the time, right? So what it goes on the top. How did we get the top? Not the x squared, the coefficient of x squared, which is, no, if it's something there, it has to be a 1. So it's the coefficient of x squared is 1 times 3 is 3 on top. And what goes on the bottom? The 4. Okay. And then we had to figure out what 2 numbers multiply together to make 3 and add together to make 4. Okay? So, Destiny, what do you think? What 2 numbers multiply together to make 3 and add together to make 4? 3 and 1, good. So we're going to put 3 here and a 1 here. So we've got 3x here. So we split the 4x's into 3x and 1x. Then you can see that the x squared plus 1x plus 3x plus 3 is going to be the 4x, and it also it works is what you'd get if you actually multiplied out your factors. So what goes here, they have, what do they have in, or let's look across this, look across going this way. They have an x in common. Okay. And if they have an x in common, what's going to go up here on top? Yeah, because x times x makes x squared. What's going to go here? What times x makes 1x? Yeah, so plus 1. It's a positive, so it needs to be a positive there. And then getting the bottom part here, what's going to go up front here? Yeah, because 3 times this x up from top is going to give me 3x. So when I factored it, I end up with x plus 1 times x plus 3 Okay, so let's take a peek at some things here. All right, so I just factored this, but we haven't talked a lot about graphing recently, and the graphing does relate to what we're talking about. So I've got a graph of this thing here. So if I actually set that equal to y equals and I graphed it, this is what I get. Look at your factors up there and look at the graph. And just quietly on your own, think about it. So is there anything you notice? And that's the question I had here. Compare your factors with the graph of y equals x squared plus 4x plus 3. What do you notice? Let's check. I got a hand raised over here, so I'm going to check on that. Okay, good. Clear this. And I did see the hand raised, so you guys know. I just checked the answer there to see what's going on. Talk with your neighbors. What do you know? Okay, so several of you, as I walked around, noticed that the graph intersected the x-axis at -3. and that it intersected the y-axis at -1, and that's very similar to what we have here and here. And you're talking about it's the opposite sign of what's here and here. And so we're going to find out why that is, because that is the relationship. There was a relationship between these factors and these numbers. They are almost the same. Thinking about what we just finished doing, where we had this, isn't this the thing this is the thing we just factored, right? We had this, but we remember what we had up here, back here? We set this part equal to 0. And what happened? When this was a positive 1, we ended up with a negative 1. When this was a negative 2, we ended up with a positive 2 when we solved for 0. Okay? So if we go back to this one, what did we do with these two factors in order to get the -3 and the -1? We solved for 0. So we can't do it the way it's set up, right? The way it was initially set up, right? But when I say that y equals x squared plus 4x plus 3, then I could say that the y equals 0, couldn't I? And solve for 0. So if I was using this equation that we just looked at right here, and set that equal to 0 and said that y was 0, then we could solve that and we'd get -1 and -3, wouldn't we? Okay. Now, why is it that I said we could set that y equal to 0? Because this is an important piece here. Where does y equal 0 on the graph? Where is y equal 0? We need to figure out why did we set that equal to 0? You're close. Okay. Checking to see if I got any. Ooh. Okay. Now, so I made an important observation from the other side of things, so I'm glad that they put that in there. Did everybody notice the graph isn't linear? Yeah. So one of the things we're doing is we're moving from linear things that make a straight line on a graph, to something that doesn't make a straight line that's graphed, and it actually has this pattern. So when you're graphing x squared, this person noticed that we have something that has x squared as its highest exponent, we're going to get this pattern actually. Okay? And so that's an important pattern. But let's go back to our question. Where does y equal 0? Well, let's actually name the points here on this graph. If I name the point right here, this name of this first point right here, that would be 1, 0, right? What's the y value there? 0. Okay? If I name this point right here, it would be 0, 0. What's the y value? 0, right? If I name this point right here, what's the, it'd be -1, 0. What's the y value? Okay. Where are all those points? On the x-axis, right? So where does y equal 0? On the x-axis. Did everybody see that? No matter what point I pick on the x-axis, the y value is always going to be what? It's always going to be 0. Okay? So that's why when we look at those points, the one right here and the one right here, that's why we could set them equal to 0, set that equation equal to 0, because the y value on the x-axis, those points are on the x-axis, right? And since we're on the x-axis, we can say the y value is 0. So that's why I could actually take the y here and change it so it says 0 equals x squared plus 4x plus 3. Because what I'm really looking for when I'm solving these equations is where, for this pattern, with what we call our quadratic pattern, because of the x squared, okay, is that we're looking for the place where the graph crosses the x-axis. So when we're finding a solution for these problems, we set it equal to 0 because we're looking for the place where the graph crosses the x-axis. All right? So again, what are we actually finding when we find the roots of a polynomial? These are called the things we just looked at, those points right here. I forgot to point that out. The points right here and here are called the roots of the polynomial, in this case, the quadratic. So what are we actually looking for when we're finding the roots of a polynomial? The place where y is 0, which is on the x-axis. And so that actually answers the next question. What are we actually finding when we find the roots of the polynomial? The place where the graph intersects with the x-axis, or the place on the graph that y equals 0. They're actually the same thing, aren't they? Okay, so let's get that down. Put this one away, please. All right. So let's try putting that all together. If you're asked to find the roots for y equals x squared plus 4x plus 3, what do you suppose the first thing is you're going to have to do? So I'm asked to find the roots, based on the fact that we know that the roots is the place where the graph intersects the x-axis. It's also the place where y equals 0. So what do you think based on that and what we've learned so far, what do you think I should do if I want to find the roots for this? I want to solve that for x, basically. What do you think is a good guess? What do you guys think about that? If we know that the roots are the place where on the graph where y equals 0, does it make sense to put 0 in for y? If we know that, does it make sense? Anthony, what do you think? Does it make sense? You guess? Why do you guess that? Because I'm saying it? I didn't say it. I'm asking you. It says find the roots right here, doesn't it? And what does it say about the roots? It's where y, on the graph where y equals 0. So does it make sense to put 0 in for the y? Yeah. Okay. So good. So let's see if that's what we got here. That's exactly the first step, isn't it? All right. What do you suppose we should do next? And that's, let me show the first step here. To set the polynomial equal to 0. And why did we do that? Because we're looking for the roots, and that is where y equals 0, right? Okay. What do you think I should do next? No? If that 0 wasn't there, what would you do? If that equals 0 part wasn't there, what would you probably do with this based on what we've been doing? Brandon, what do you think? What did we just finish doing a little earlier? We had this very same thing. What did we just do? You remember that, Maria? Okay, we graphed it. We don't have to graph it to find the roots. We could. But remember, let's go back and look. We did have a graph, but we also did something else, didn't we? Yeah, that's called factoring when we're doing that. Okay? You're good. Good. Excellent. Okay? Does that make sense? Because what we found out by looking at this is that when we did factor it using these tools, we got this, and that if we set that to 0, we would end up getting the -3 and the -1 based on what we learned about zero product property, right? Okay? So the next thing we're going to do is we're actually going to factor it. That's the next step. Okay, so let's get that down if you don't have it down already. So you have the steps in your notes. So if you're home and you get stuck, then you go back and look, right? You're very good at talking about this. What do you think you should do next? After this step, what makes sense? We'll look back at your notes and see what we kind of talked about earlier. Might help. What did we do earlier? When when you had this situation earlier, what did you do? You've got to know. Let's go back and look. If you don't have this in your notes, it probably wasn't part of something you should have had down. We had something like that earlier, didn't we? What did we do? Monique, what did they do there? What did we do there? If something equals 0, if two numbers are multiplied together and it equals 0, what do we know about one of those numbers? Two numbers are multiplied together, the answer is 0. What do we know about one of the numbers? It has to be 0. Okay? And remember that the x plus 1 in this case, the x plus 1 could be 0, or the x minus 2 could be 0. X plus 1 is a number. X minus 2 is a number. Do we know which one is 0? So if we don't know which one's 0, then we go ahead and set them both equal to 0. Okay? So let's go ahead and do that. That's the next step. Set each part equal to 0. And I'm going to let you do that and then finish solving it. Figure out where x is worth. We're trying to solve for x number here. Okay, so most of you did a good job with that. It kind of took a little bit. You weren't quite sure if you should put it down. You were being a little hesitant, but you were on the right track. You were thinking the right thing. So we have x plus 3 equals 0 and x plus 1 equals 0. We don't know which one, so we do both of them. Okay? And we do that because of the thing called the zero product property. So we applied the zero product property there. And then when you solve everything for x, you end up with x equals -3 and x equals to -1. And that was just, we did that because we solved for x. So again, what do these numbers represent in terms of the big overall picture? If we think back to the graph, those numbers represent the place where the graph intersects with the x axis, right? Okay? Where the y value is 0. Okay? Next one. Now what's different about this one from the one before? Okay, it has -5x, so what else is different? You want to look at the one we did before. What did it say? That one said y equals something, didn't it? Did it say y equals? No. So what am I going to do with this one? What do you think I should do with this one? Is it the same format as the others? Okay? The first step would be to get it so that it's in what we call standard form. And when you do that, guess what happens? It ends up equaling 0. Okay? So sometimes it says y equals and you have to put a 0 in for the y. Sometimes it doesn't have the y equals, but if you set it up, you get sort of equals 0. You get into the next step. Negative 36, one of the factors that is mentioned to be positive, one thing has to be negative, right? Negative 5. Two results I get to make 36. Okay? So we've got 9 and 4, one of them has to be negative. Since our 5 is negative, we want the bigger one negative, so that's going to be negative 9, like was mentioned. So we got negative 9 and positive 4, and we do that because we factored. Some of you, as you're doing this, are just putting either like the problem down and not putting the steps down next to it, or you're just putting the steps down and not putting the problem next to it. And that's going to confuse you later. That's why I put both side by side, is because then you can see what happened in terms of the math and what we did in terms of the words. Really important to have both of those things there in your notes so that you can make sure it's understandable for you when you go home to try and do it on your own. So what's the next step? Is each one equal to 0? Does everybody agree with that? Okay, so do it. Let's finish it up. So you kind of got some things down, and you're going to just check and see if you're on the right track. So are you on the right track? Yeah? And then get those answers there. So let's make sure the steps are there. Think about why we make it 0. Why did we set it equal to 0? Because we're looking for the place where y equals 0, right, on the graph. Why did we do the 0 product property separate them out? Because if it equals 0, one of the two numbers they're multiplying has to be 0, right? And the solutions represent the place where the graph intersects the x-axis. All right, so I got another one for you to do. I'm going to just kind of show you the quick little thing on this. That says cubed, doesn't it? But if I'm factoring, the first thing I would do is I see they both have a 3x in common. So I'm going to factor the 3x out first, and then the 4x squared. I'm going to leave some space here intentionally, minus 1. Okay? Is that missing something? Does it look like it's missing something? All the other ones had x, just regular x's, not x squared. Yeah, they had x squares, but they also had x's, didn't they? This one doesn't have x's, does it? But it does, doesn't it? If it's not showing, how many x's is it? If there's nothing there, how many x's are there? 0. So you could actually, if you wanted to, you could think in your head that, but you could actually write down that if you wanted to as well, if that helps you as you do your diamond problems and so on. Okay? And then you can finish that one. All right? So that's exactly, you take that inside piece, and it says f of x, which is the same as y, so the whole thing would have to be equal to 0. Okay? Makes sense? Same, is there really anything different about this than the others? No, it's just that I had that 3x. And guess what? In this case, you're going to end up with 3 numbers that have to equal to 0 at the end. Same process, though, non-new process. So the last thing is I'm going to ask you, what does it mean if you get 3 solutions for your polynomial equation? What does it mean? What do the solutions represent again? Where the graph crosses the x-axis. So if you have 3 solutions, how many times does it cross the x-axis? 3 times. What about if you had 1 solution? What does that mean? The graph only crosses 1 time. What if you had 14 solutions? It's going to cross 14 times. What if there are no solutions? It never crosses the x-axis. Okay? So something to kind of keep in mind. Good job today, guys. And I will hopefully, I'm hoping some of you guys, you're right there on the board. I hope you get some of those grades up so you don't have to come in next week unless you want to. Okay? So have a good day.